Today we're going to talk about metric conversions. We use a system called the SI units. This is the International System of Units. It's not necessarily what you have grown up with your whole life. We're not using the American system for the units that we're talking about. We're using the International System of Units. As the year goes on, we're going to learn a lot about the different units that are part of this system. But for today, we're just going to focus on our length, volume, and mass. So the length that we're going to be using is meters. We can shorten this to a lowercase m. For volume, we're going to be using liters. And this can be a capital L. And for mass, we are going to be using grams, and that's going to be a lowercase g. These three units are going to be known as base units. Now, we're calling them base units because they are the primary unit, and we're going to be putting in front of them different prefixes that tell us how big or small these units are. So some of the common units that we need to know are kilo, centi, milli, and nano. You are responsible for knowing how many base units or how many prefixes fit into your base unit. So we have to know that a kilo is bigger than our base unit. It's a larger unit. In fact, 1,000 grams fit into 1 kilogram. And I'm just using gram as the example. Meters could fit there, liters, grams, and seconds. But the amount of kilos equal to the base unit is always going to be the same, no matter the base unit that we are using. Another way to write 1,000 is 1 times 10 to the third. I tend to put things into scientific notation. The more zeros there are, the more I'm going to require you to do that, but it's not necessary for the kilo conversion. Centi, milli, and nano are all smaller than the base unit, meaning that more of these fit into a base unit, which is why our conversions look a little bit different. So these are smaller. So here we can see that 100 centigrams is equal to 1 gram. This could also be rewritten as 1 times 10 to the second. Milli is even smaller than that, and it says that 1,000 milligrams fit into 1 gram. Again, we can rewrite this as 1 times 10 to the third. Nano is probably the one that you're least familiar with. Nano is really, really small. Here we have 1 times 10 to the 9th nanograms fit into 1 gram. You need to have these prefixes and what they mean memorized. This is really important. We are going to be using metric conversions throughout this entire year. Let's see how this plays into some practice problems. First problem we have here are how many grams are there in 2.4 kilograms. Now I have a very specific process on how I want you to complete these problems. It's called dimensional analysis. And the way that we do this is by looking at the units that we have, by crossing out units that we want to get rid of, and converting it into the unit that we want to get into. So what I like to do is point out what we're given and what we are looking for. So it says how many grams, this is what we are looking for, are there in 2.4 kilograms. This is what we were given. So the way that you're going to set this up is always with what you were given. So we have 2.4 grams is what we are starting with. Kilograms. Now, the question is asking for grams, which is telling us that we have to get out of kilograms. I set up something called railroad tracks. Now, throughout this year, we're going to be doing different types of railroad tracks that have different number of steps. For metric conversions, you can tell how many steps there are based on if you see just the base unit. Here, we have grams without a prefix in front of it. So that means that a base unit is there, and it's going to only be one step. If in the problem you cannot find a base unit without a prefix in front of it, that means that it's going to be multiple steps. So, but this one, we do have a base unit in, so it's only going to be one unit. So, in order to get out of kilograms, we have to put it on the bottom. Think of this horizontal line as a division sign. If you were to divide kilograms by kilograms, they would cross out. So we're getting out of kilograms, which means that we need a new unit. The new unit we're going to try to convert to is grams. So that's what goes on top. Now, we have to figure out, well, what numbers am I going to put in front of here? In one of these railroad tracks, the top and bottom in the same section have to be equal to each other. Well, we previously just went over kilograms and grams and how they are equal. So here it says that 1 kilogram is equal to 1,000 grams. So next to grams, I'm going to put 1 times 10 to the third, which is the same thing as 1,000, is equal to 1 kilogram. Now we just said that this horizontal line is like a division sign. This vertical line is like a multiplication sign. So what you want to do is everything that's on top, you want to multiply together and get an answer. Everything that's on the bottom, you want to multiply and get an answer, and then divide top by bottom. Here on the bottom, we only have a 1, so that makes our life a little bit easier. So in your calculator, what you want to do is 2.4 times 1 times 10 to the third, or times 1,000. And you should get 2,400 grams. Now you can convert this into scientific notation, which should be 2.4 times 10 to the third grams. Make sure you always have a number and a unit. Okay? How about you try the next one? We want to know how many nanoliters are there in 6.34 times 10 to the 6 liters. Remember, figure out what you are trying to figure out, where you are going. Then you want to say, is there a base unit in there? If there is, then it's only going to be one step. If there is not, then it would be multiple steps. I'm going to go ahead and put the answer up here to see if you can get my answer. Let me backtrack. The question is asking for nanoliters, so I know that has to be my ending unit. I'm starting with 6.34 times 10 to the 6 liters. The liters does not have a prefix in front of it, so I know that it's only going to be one step. So I always put what I'm given in front. One step, so I only need one section in my railroad tracks. I know that I do not want to stay in liters, so I put liters on the bottom, and the question is asking me for nanoliters. Nano is a little n. So then I go back and say, all right, well, I have 1 times 10 to the 9th nanoliters for every base unit. So I put 1 times 10 to the 9th for every 1 liter. Again, I can multiply across in order to get my answer. Let's try the next one. How many millimeters are there in 2,489 centimeters? So here, I know that I'm looking for millimeters, and I am given centimeters. This one is going to be different because I am not given a base unit. So I know it's going to be more than one step. So what you're going to do is you're going to start in centimeters, go to your base unit, and then go from your base unit to the new unit. So it's actually going to be 2 steps. But we're going to set it up the same way. So we're always going to start what it's given to us in the problem. Okay. Now, I said that I always want to go to my base unit. In this case, my base unit is meters. So I have to get out of centimeters and get into meters. Now, the question is not asking for meters, so that's how I know I need to set up another step. And just like I did before, I have to get out of meters and into the unit I'm actually looking for, which is millimeters. Again, I look at my conversions. I have to know how many centimeters there are in a meter. I have to know how many millimeters there are in a meter so I can set up my conversion factors. So I know that for every 1 meter, there are 100 centimeters, or 1 times 10 to the second. Here, next to millimeters, I know that there are 1,000 millimeters in every 1 meter. Like I said before, you want to multiply everything that's on the top, get an answer, multiply everything that's on the bottom, get an answer, and then divide. So the answer that you should come up with, actually, go ahead, take a second and see if you can come up with an answer, and I'll show you my answer. Notice how centimeters crosses out with centimeters, meters crosses out with meters, so I'm ending in that last unit, which is what the question asked me for. All right, last one. How many nanometers are there in 3.2 times 10 to the negative 3 kilometers? So you have to ask yourself the question, where am I starting, where am I going? Is there a base unit in there? Is there not? How many steps is it going to be? We have nanometers and we have kilometers. There is not a base unit. It's going to be a 2-step problem. For this one, I want you to solve it completely on your own. I'm going to put the answer at the end. There is your answer.